much time we got left. All right, I gotta get this done in 1 hour and 47 minutes. I think I'll be good.
How long, man?
I know, my other ones are a little bit lengthy. So, I did find this public license, which was pretty hilarious.
Yeah, I read that the other day.
Yeah, I sent it to our group, and then it's like, this was built in 2004, and it's the do the fuck what you want to it public license, version 2. And this is a valid bureau. I mean, you go there and it'll show you the license, and then if you go to the actual site, it tells you why you made that license. It's basically more open than GPL and stuff.
Was version 1 too restrictive?
That's what I said, but I can't find version 1, so I don't know. Maybe it started with version 2. They like to screw around with people. This is the same script as I did last time. So as you can see, I have versioning things in here. So I have actually changed my name designation in here. But last time I built most of it, and then today I've updated it with some additional functions for the second presentation. Yes, sir.
Do we need this script if we want to follow? Like, is there a place for us to download the script or something?
There is not, but I will provide you with the script as I promised to do last time, and I didn't. So I promise to you again, and it will also get videos too. So give me time. I'm lazy. I'm lazy and I do this for free. So
you said that you promised last time and you still didn't do it. So how do we know you're going to fulfill this promise?
You don't. Give me more beer. That's all.
Is that where you will decide will work for beer?
Yeah, there you go. So if you're interested in this, let's go look at this because it's funny. Programmers have a lot of humor in their material.
Say everything else.
Yeah. You can't leave.
You think I wouldn't do sooner?
So that's the license.
Copyright 2994 or 2000.
Numbers, they're things. Yes.
There you go.
That's the actual license.
That's awesome.
It's fantastic. It's full of expletives and fun things that children shouldn't do. All right. Best used with Vim, of course. No, you can use whatever you want. So up here, in the top end of it, I gotta make this a little bit smaller. I can't deal with that. All right. So later on, we actually have some colors being introduced. I'll show you guys how to do some color bits. So here in the very beginning, I actually define the color I want because resetting colors is kind of a pain.
Dan, can you rehash what this does?
It changes. Oh, yeah. Rehash the actual script.
Yeah.
So this script is a script that I wrote to teach you how to learn Bash. It builds on this presentation today. It builds on the presentation we did last month. So if you missed last month, go look at the video that's not on there. Cool. So I'll quickly rehash what is in the script from the first one. Very, just like run right over it, and it'll take us like 5 minutes, 5 minutes, and then we'll go on to the new stuff. So here we have a function. Functions are very integral to higher-end scripting. What you do is you make code snippets that you will then later on execute whenever you feel like executing. So this is a function. It's called menu. I don't have anything tabbed out because I don't like wasting space sometimes, like it depends on what I'm doing. But for a function, I usually don't tab out. For if statements, anything like that, I usually do. Because functions are giant code chunks. I don't really feel the need to tab out for that. So, here I say clear. Clear is to get rid of everything on the screen. I tell the user some stuff. And I select action. This builds a menu. I've added some things to the menu. I've added set function, privilege escalation, combo colors, and row. And then it says, hey, what's your choice? And we'll see that in a second. And then I have a couple of different ways ways of doing the calls to the different functions. We covered that on the first one, so I won't really recover it, but we basically say if the variable is whatever, then call that specific function. All right, and this is what it looks like. That's what the menu looks like when you actually do it. All right, and if you do, say everything says, get it on the way. All right, and get back to land. All right. So, do is a function. We're not going to go over the functions we went over last time because we went over last time. So do is a function, it runs the video. Tux is a function, it's a fun little thing where Tux wants a fish and you give him a fish and he's happy. Expansion is a function, shows you how bash expansion works. Arrays is a function, and it shows you how arrays work and how you can pop things into arrays. So these are the functions that we've written for today's presentation. This is a sed function. This is a little bit more advanced usage. So if you're trying to do something on the command line and you want to take the output of one command or a file that has particular data in it and you want to manipulate that data, you're going to use, generally you're going to use sed or awk. Sed is the stream editor. Awk means awk. I actually don't know what it means. So here, I'm going to tell you what it does and I'm going to show you what it does. So this function, the function sedif, because sed is a special word in this, so I want to name the function sed. Because if I call sed, like if I say, hey, run sed, then bash is just going to be like, sed what? Because sed is a special, it's an actual function. You can see it being run right here, actually. And so I can't name the function sed because when I call it, it'll break. So I called it sed for sed function. All right. So here I say sed var equals the red duck pole vaulted over the building. All right, to make up some crazy thing. Now I say echo. This is the original colon, and then I tell echo to print out the variable. So it's going to say this is the original, the red duck pole vaulted over the building. All right. Simple enough. Then I say echo minus n. Now the minus n flag tells it to not provide a new line. Okay? So it's going to say this is sed modified colon space and then not do a return character. All right? Now it terminates its running at the end of that. Then it runs echo sed var. So it takes this thing, it drops it into standard output. The pipe pushes that standard output into standard in of the next program. That next program is sed. Now sed, there is literally a book. It's like that thick. That's on sed awk. It can be very simple. I use it very simple in a very simple method to just basically find and replace things. But there's a huge amount of things you can do with sed and or awk, and a lot of them actually move over each other. You can do a lot of the same things with one or the other. So if you become very specialized in one or the other, you can actually do a lot of things that might be more designated for the other command. But that being said, sed is our choice here. So what we're going to do is we're going to take this string, we're going to pipe it into the input of sed. Okay, that's what the pipe does. Sed then says, hey, search for red. Replace it with green. Okay? So now it's going to say the green duck pole vaulted over the building. Now this is one case, so like this may not seem really super useful right now, but when you're a sysadmin and there's like 45,000 red and you need to change all of them, and you need to do that every 5 minutes on the system because it's outputting this material, sed's suddenly very useful, okay? Because one, you could do all 45,000, something like Venom or manually if you really were sadistic, but you can't do that in a timely manner. either way, because in Vim you have to open it up, you have to change it, to write it. Manually, just forget it. You're not doing it 45,000 times. Like, it's ridiculous. You're going to miss something. It's going to be bad. All right, so we're programmatically going in here and saying, I want to change this value to this other value. Now, you can do that for all kinds of stuff. All right, so that's a very useful command to know. If you're going to do stuff for screen editing, there's a lot to it, more than just changing stuff out. So let's go ahead and look at the first one. So we're going to do the setup one, which is number 5. All right, and so we can see the red duct pole vaulted over the building, the green duct pole vaulted over the building. All right, so that's very super basic setup. Now there's a whole bunch of more into that, but we're not going to go into that. We don't need an entire year's worth of lugs on one program. The next one is TR, translate. All right. Translate's also useful. Not only can you encode things, so you can do like, I believe you can do ROT64 coding. I'm not sure, but you can actually like go and change things to be other things. So you can say like A through C, or you can change A-C to Y-Z, and every time there's an A, it'll change it to a Y. Every time there's a B, it'll change it to an X, and every time there's a C, it'll change it to a Z. There's all kinds of crazy things you can do with TR. This is one of the simpler things, which is just changing the lowercase to the uppercase. So it finds an alpha character that's lowercase, and it says, oh, you're a lowercase character. Changes it to an uppercase. Easy, right? So I just do that same thing. I grab that set bar, which is this guy up here, and I pipe it into TR. So it takes the output of echo set bar, it puts it into the input, standard input of TR, and then TR is configured here to say, I want to change all lowercase variable, or all lowercase characters to uppercase. All right? And so what we end up with is a capitalized version of setbar. All right? Now it's not changed because we didn't change this one. We just changed what was being displayed. This one we changed, instead of it being properly cased, to all uppercase. Now again, TR can be used for a great number of things, but it's useful to know that that exists. Are there any questions with that particular function? Hit return to go back to the main menu. Read. Now read without anything is almost useless, except it's great with menus. All right, so you just say read, and it's waiting for you to hit return. I can type in the whole dissertation and then hit return, and that goes nowhere. All right? So it saves it, it doesn't save it, it just waits for the user to hit return. And then once the user hits return, it continues. And so it displays this, go back to main menu, and it says read, it waits for the user to hit return. Once the user hits return, then it calls the function menu, it goes back to the top where our menu function is, and continues on. All right, next we have privilege escalation. Privileges are very important on Unix systems and Linux systems. If I do not own the file and I do not have the right permissions to that file or directory, I won't be able to write into it or read into it or do whatever the permissions tell me I can and can't do. So for this example, I've made a directory called root owned. Okay? Now I've actually left that root owned as a normal directory. If you look at this, I actually didn't use pointer zone, so we can actually get rid of that, but root owned has the normal directory usage. So it's read, write, execute for the user, it's read, execute for the group, and then read, execute for everyone. Now what that means is I can go into it, and I can look what's in there, but I can't write things that are not owned by me in that directory. Now if there's a file in there that's owned by me, I can actually get to it, manipulate it, even though this directory is owned by root. But since there's nothing in there, I can't do that. I can't write new files in there because I'm not And nor should you ever be, unless you need to be. That's a big thing. New sysadmins, some new sysadmins, especially ones that are coming from the Windows world, run everything as root. That is super bad. Don't ever do that. The reason it's super bad is, one, there are no safeguards against you. If you mess something up, it's just going to do it. You tell it to remove recursive force / guess what? You don't have a file system anymore. Congratulations, because root is God on the system. The other more, right, and there is no trash bin in this. The other more insidious thing is, let's say that you run Apache, you run like a service, you run some kind of an application as root, because you're like, it just doesn't run as me, I need to just run it as root, right? Just think of it like that. You're running Firefox, right? Something's messed up, let me just run it as root. But what happens when you go to a compromised web page? Well, guess what? There's no path between it and root. Now it's just root. Now it owns your system. Hands down, you're just done. Otherwise, they would have to try to it gets into your user, and then it has to try to do some kind of a root privilege escalation, and then do all kinds of other stuff. That's also why you don't want to do sudo with no password, because that means that your root, the user that you're running as, is root. I just type sudo, and I'm root now. I don't have a password or anything. So you have to be careful of how you configure sudo as well. So you have to take these things into consideration when you're protecting a system, and that's going to be all systems, not only your system, but others. And one of the things I've seen some security people doing, which is fairly disturbing, is they run Kali on their system. They install it on their system. And that's dumb. And I'll tell you why it's dumb. And it is that everything is running as root. You log in as the root user to the system. Now, Kali is fine running as root on a non-permanent unit. All right, you don't use this for every day. Or even if you install it and you wipe it every time you use it, or you wipe it every week or something, and it's just a pen testing box or something, that's fine, totally okay. But somebody's going to compromise you, and they're going to have immediate root access. That's just still cookies. It's bad. All right, so. Just as this is why the system is built like this. It may be irritating at first, but just learn how to deal with it, and that makes you safer. All right, so here, we're root. We're not root, I'm Dan, right? So this one's actually the presentation.bash is owned by Dan. And I'm doing root own. I'm trying to put things in root own. So here, we have 3 different ways of putting data into a file. All right, so we have echo foo, so it's going to just literally display foo, redirect into root-owned /foo. So it's going to redirect into this root-owned directory, which remember is 755 /foo. Oh, and the 755 is a number escalation of privileges. Each privilege has a number count. So read is 4, write is 2, and execute is 1. You add those together, and you come up with that number. Okay, so a 5 is read and execute, and a 7 is read, write, and execute. Okay, because you add the numbers together. So this script, running as me, running as Dan, is trying to write into a root-owned directory, which is read execute, so it's 5. Shouldn't be able to. Echo foo into that. All right. Sudo super user do echo foo2 into root-owned /foo2, and then sudo super user do bash command quote echo foo3 redirect root-owned foo3. Who thinks that foo will work? All right, you guys are listening. Who thinks foo2 will work? Yeah, I got some of the crowd. Okay. Who thinks foo3 will work? Still, come on, you have a little confidence. Okay.
dash C do?
It runs the command. So if I run my presentation again, now see there's nothing in root on it. And I say privilege as presentation. Alright? Whoops. The script will tell you if you can't write there. Whoop. Alright, so I have to type my password because I don't have root with no password on there. Okay, now go back to the main menu, exit. So I'll tell you why the first one and the second one didn't work. The first one didn't work because my user doesn't have privileges to write there. Straight up. It's just not going to work. The second one doesn't work. And this is where it's tricky. The second one doesn't work because you're running echo as root. It then redirects, which is a new command, into this directory. Now this is running as root. This is running as data. All right? And it'll get you sometimes. So if you need to run something, and this will count along with if you're trying to do things with SSH, if you're SSHing to a remote system, which is very common in the sysadmin world, and I'll be showing that as well. If you want to run multiple things, or if you want to put data in different places, you have to be very aware how you're passing that data. So here, I say sudo bash. I'm actually running bash as sudo. I'm telling it, hey bash, run this command, that's the -c, and then I give it a command in quotes. So it runs this entire command as root. Okay? Are there any questions? You guys having fun? Bored to death?
Never.
Well, this is the fun stuff. This is the kind of stuff I write at work. This is a fairly simple one, but when you get to be in the sysadmin and you start playing around with different things, you're going to see this actually quite a bit. Okay. Now this is what's called a inline shell script. All right. So it's a shell script that's trying to do a specific purpose. I'm writing it on the fly. It's probably not going to be run every time, but you can write, like I did put this into a script right here. It's a file that I'm running. But a lot of times you build inline shell scripts to just handle things that you're doing on the command line on the fly. Okay? So, as we did last time, we have our for statements. So we have for I in. I being our placeholder. So whatever we're putting in after in here, which is this, it's going to be placed into I. Okay? So for I in, find, it's executing this because of the single ticks. Find var log, and ticks being not single quotes but ticks is the one, it's the tilde. It's the one that shares the tilde key. So find var log. So what it's going to do is find is going to go to var log, and it's going to try to list everything. And then within those parameters, m time minus 30. So anything within the last 30 days, anything with a timestamp within the last 30 days, and with the name, messages, dot, single character. Question mark is a regex for single character. If I did a star, it would be anything. But here, I only want single character. Now this would break it if there was double digit backlog. So if my backlog went to like 15, 10 through 15 would not match this. Okay? So you gotta be careful there, how you designate things. But this is regex. Regex is kind of more advanced, so like if you don't, you can spend days on that and still be like, what the heck's going on? So question mark is single character dot gz, so gz. Okay, now I know the specific thing that I'm looking for. So it's going to be 30 days or newer, 30 days old or newer, and it's going to be messages dot something, one character, dot gz. It's going to find those. Okay, Now, this is a root owned directory, var log, on my system. But my user can read them. Okay, so it's going to give me a list. It's probably going to give me two things. Then it's going to do, which is the end of that if statement logic, right? Sudo, our friend sudo, hey, super user do, zgrep. I don't know if anybody's seen zgrep before, but zgrep is the gzip grep. It will actually read gzip files. It's great when you're looking at logs and stuff. So you don't have to extract the file, you just use zgrep. You can also use zcat. It's cat, but for gzip files. So zgrep, use it just like grep. Zgrep, ACPI, $i. So everything that this thing finds, it's going to put into I, and I'm using that over here. Okay, so zgrep, ACPI, $i. Pipe that output, so the standard out, which would usually be shown to me, instead of showing it to me, pass it to the next command. The next command is another grep. It's not gzipped anymore, so we just use regular grep. All right, cool. Grep, quote, EC colon. So I'm looking for EC colon.
EC being error code?
It was just something I saw in my logs. It's not error code, it's some kind of designation or something. I was just looking for something that happens a couple of times in the logs, just to kind of see what's going on. Semicolon, done. All right, we'll go over what semicolon does a little bit later, but basically it's a separator between different things going on. So this is the end of the if statement. Right? So our if statement goes from, or our for statement goes from here to here. Right? So it's finding things, it's taking that output, it's going and grepping things out of those files that are in that output, grepping for further reduction, and then finishing. So it's just dropping that into standard out. Now, yes?
Your done completes your do.
Yeah.
You said the done completes the for.
It does.
No.
For is part of do.
No. The done completes the do.
Okay.
And it does not complete.
Well,
It does the next line.
it completes the entire logic, but yes, it is. Possibly messing with my trajectory. All right, so yes, the entire logic of the for is between for and done, but the for to do is what is designating the I, and then every time, every value that this for comes up with, it runs a cycle between do and done. Okay, so I think that's probably, I get why you said that. That makes more sense to probably, because for somebody that's new with logic and stuff. So this is going to find two values, right? It's going to find two files. It's going to find var log messages dot probably 1 and 2 or something like that. It's going to put this in, and between do and done, it's going to run sudo zgrep ACPI $i pipe grep EC for each one of those values that got found. Okay, so there's one logic statement, but it's going to run this code block twice. All right. Then it's going to dump the output of that code block into standard out. Well, we have a pipe here again. So we're just dumping that into the next program, which is our friend awk. One of the most useful programs when you're sysadmin. This thing is great. Right. Yes, sir.
I don't have awk in my /bin. Is that because
You should. You might not find. It might be a user bin.
Oh, okay.
Just
okay.
type which awk. WHICH space awk.
Yeah, it's in here.
There you go. Awk is a very ubiquitous program, just like SED. It's pretty much on everything, so on every system. Again, you'll probably find VI on every system. You might not find VEM on every system. You might find Nano on a lot of systems, but not on every system. VI is pretty ubiquitous. Bash is fairly ubiquitous. awk and set are fairly ubiquitous, so there's different utilities you're going to find everywhere, and some you're going to find in some places. And as a sysadmin, you're not going to necessarily be able to install things in environments a lot of times, so you just have to deal with what you have. So you have to be kind of careful with things, but yeah, awk and set should be pretty much everything. So we're going to drop awk. Now that probably means something really fancy that I just don't know. So I'm going to look it up at the man page and...
Awk stands for the last names of the 3 people who created it.
There you go.
Well,
And who are those people?
Oh, God. Hold on, if I say on the Wikipedia, I do. Alfred Au, Peter Weinberger, and Brian Klingham. Kernighan.
There you go.
Kernighan, yeah.
All right, cool. So now we know what awk comes from. Great. And it's a great program. So awk, and now we're not doing a field separator or anything like that. Now a lot of times I will do that, and that's a -F. So let's say we wanted the field separator to not be space, which is the default. We would do a -F and then whatever else we wanted to separate it. So we'll say we're just going to take the standard, which is space, and we're going to print over here $1 underscore $2 underscore $3. Now what that means is I want to print the first thing that shows up, the first field, and those are separated by spaces. Then I'm going to print the second field with a underscore in between, and then another underscore, and I'm going to print the third field. Then I'm going to print sorted, so I'm going to drop that into sort, so it makes sure that everything's sorted by the first field, which is the first column. Then I pipe that into unique-c. Unique-c does an interesting thing where it actually counts for you. So it shows you how it'll crush everything down, so that only the unique values show up, but it will count for you. So it'll actually show you how many counts that is. And then it pipes it into T, combo that out. Now T is a fantastic program I learned about a couple of years ago. And I've been talking too long. My laptop decided to go to sleep. All right, so T, what it does, and this is fantastic, it takes whatever comes in standard in, and it splits it, and it puts it puts everything on the standard out, and into a file. It's fantastic. So, and then I do echo nothing to give me an action space. So let's take a look at what that thing does. I did not run that before. Let's fix it. Compose. There was a space here before. And then when awk got a hold of it, it said the field separator is a space. So this one is number 1, this one's number 2, this one's number 3. And then when I told awk, hey, I want this particular output, I said I want number 1 with a underscore, number 2, and an underscore, and then number 3. And that's what it gave me. So I have number 1, an underscore, number 2, and underscore, number 3. Then I told it to sort it because it's got a specific output. Right? So I want everything to be sorted so that unique will actually make sure to get all of the different unique identifiers. Unique then crushed it down and told me the count. That was the -C. So we had 7 of these entries, and then we had 4 of these entries, and we had 4 of these entries. Okay, and this can be very helpful for like, hey, how often is this happening in the system? I'm seeing this error, and it's happening, and I have these date stamps. What I do is I'm going to crush these things down or sort them and see what it is, and then I can like lop off different things, so I can say like, all right, awk, give me this, but then do a second awk, give me a field separator of a colon, and say I want just the first value. All right, so it only gives me hours as opposed to hours, minutes, and seconds. And then I do my unique and my unique C. And my sort into my unique C. And then I'll say, okay, we've had people hitting this HTTP server and getting a 404, and they're getting a 404, 7,000 times at 8 o'clock, 20,000 times at 9 o'clock, 30,000 times at 10 o'clock, and 2 times at 11 o'clock. And so we can see like what's going on in the system, and then we can start troubleshooting and looking around on what's going on. Okay? Any questions on that? That's a little bit on the more complex side. Yes, sir.
Sorry to ask this question.
All questions are good questions.
So does your system have to be set up a certain way to output error messages like that? Like, is my computer keeping logs on error messages for everything, and I just like?
And not everything. You have a log daemon, and the log daemon will be configured to handle logs in a particular way, and you'll generally not have. There's different log levels as well, and so you can have like debugging logs, or error logs, or warning logs, or there's lots and lots of layers of logs. And so a lot of times system resources are built to generally show warnings and errors only, maybe info, but not debug. So you're not seeing like, hey, it's calling this thing that you should never need to see unless you're actually debugging the program. Like, hey, Apache's acting weird and we're doing something kind of funky, and we need to see if like this application's actually talking to the web stack properly. Then you might want to turn on the debug logging and see exactly what it's doing, but then it would start filling up your file system really fast. That's why you don't have it on usually. And so each application has its own log data. And some of them use syslog, which is what we were just looking at. We were looking at syslog. But others implement their own log daemons or don't have log daemons at all, and you just have to look at what's coming out on standard out. So it's an application specific thing on what you're trying to troubleshoot.
And do I just go, like, because I have a web browser that I use, and it works fine sometimes, but sometimes it just like randomly just like stops, and I don't know why.
What I would do with that is run the web browser from, maybe even do a bash minus X space and then execute the web browser, so like Firefox or whatever. And what it'll do, I'll show you. It's pretty neat. So let's say I have a problematic program, right? So I have Firefox-bin, that's Gen 2's Firefox binary, not the one you compile. And let's say I run Firefox bin, right? So it just executes it, and it actually just left it, which I wasn't terribly happy about. Let's see if we can do bash minus X. Okay. Now it spawns. What it's doing is it's actually spawning a child and detaching it, which a lot of times you wouldn't. In your case, you may still have that same thing. That might just be how these programs work. Most programs, you can actually sit down and be like, okay, I need to run this program, and it's having some problem on initialization, or it's not telling me what's wrong with it. You can run bash minus X and then the program name, and then what it does is it actually, bash will say every single thing that it's doing. And so like, if I wanted to do like bash minus X emerge search Firefox. Right.
Bash minus X on Firefox.
What's that?
The Firefox bin is calling off Firefox.
Oh, that exactly. Okay, so it's just a link. So I can do bash minus X. It was worth a shot. So it's a loader. So we could look into that if we wanted to. So that should work. Let's see. What did it say?
We're not going to work with this anymore.
Plan on fun. So that's the way we troubleshoot a lot of times. Troubleshoot commands in our workplace is like if there's something wrong with a particular program and it's acting funny and it's not logging sex to see what it's doing along the command line. Let me think of a good program that might do this. I don't even know if that works on this. Yeah, dude. Oh, that's gonna help with, let's see. That's not right. There's something wrong with how I'm doing that. So anyway, there's different ways you can get it to output more verbose material and
Set meshes.
what?
Set meshes.
Well, that sets it for everything. But bash that set usually we run directly because we just did it with Firefox. It worked. I don't know why it's not working for this flag.
Because that was a shell script. That was the line here.
Right. What we can do. Yeah. Yeah, well, see that plus curl over there? Maybe you just didn't like the implication that I was doing in this particular system. But this right here was not usually curl. So if you just did curl google.com, it's not going to show you that. So that was the set by sex. And the X is kind of a debug for bash. And so it'll show you that everything bash is doing, but it's not going to show you necessarily everything the program is doing. Then you have to start going deeper into it, like by doing string lookups and stuff like that. I guess some like program. So did that answer your question?
Oh yeah, that answers my question. It gives me something to do in my phone.
Cool. So much of that.
And by the way, if the program crashes, it may usually, even no matter what you do, it might dump to log somewhere.
Okay.
Some helpful bit of information.
Right.
Like I know Chrome does that, if like Flash or whatever causes the whole thing to crash, it'll dump to send it out with one of that. Like, something awful happened. And this gives you a direction to go with.
Yep. And you can maybe potentially get core dumps as well, where it actually dumps
Get
the
what?
memory. Core dumps, where it actually dumps the memory of the running process.
okay.
The kernel will grab the memory of the running process before it exits and cram it into a file, and then you can debug it by taking that core, extracting it, seeing what it was running at the time, what was in the running memory, all kinds of stuff, and that's pretty amazing. I would do more on the application, the person that's actually building the application, or an advanced user.
Firefox has an automated core dump analysis.
Yeah.
So if you have a core dump of Firefox, you can submit it to the site, and like an hour, a couple hours later, they'll send you an email about what happened,
Okay.
based on the memory analysis of what, of the final breath of Firefox.
That's pretty cool. I hadn't heard about that.
Yeah.
That's really
That's how they automate so their guys don't have to deal with millions of core dumps.
I understand that. All right, so pipe exit status. Pipe exit status is very useful. It's something I actually found out about fairly recently. If you have a program that has a whole bunch of pipes, like the last one we were just plugging with, and you're like, I need to see the status of the exit code of number 6 out of 20, right? So it's got 20 things. It's piping this there and moving all stuff around. I want to know if this specific command, which is prone to failure, fails. And if it does, I want the whole thing to fail, or I want to do the specific action or something. What you can do is you can actually type pipe status, and it will tell you the status of the thing in that particular line. So here I have false pipe true. And now that doesn't actually do anything for us, but it shows us how this works. False is going to report 1 as its exit status. True is going to report 0. All right, so echo, first pipe status 0, second pipe status 1. All right, so this is kind of like our question mark or docs on question mark, except we can be more finite about it. We can say, like, I want the exit status of this specific pipe location. And so if we go back to console again, here's our pipe status one. So first is 1, second is 0. So 1 is fail, 0 is okay. All right? It's very useful. redirects. Redirects are an important thing to know. Oh, we didn't skip one. Inline logic. Both of these are really important. So inline logic, there are pipes, which we've covered very well up to this point. But we haven't really covered semicolon or ampersand ampersand. Semicolon says exit no matter 0, semicolon. Right? So it says, okay, I'm going to run the next command. These are ways of running the next command. So you can string a whole bunch of commands together that have nothing to do with each other. You're just running, basically, instead of running it one, and then the next one, and then the next one, you're just stringing them all along on one command line. So up to this point, we've been passing the data from one to another. We're actually kind of going back in time to a little bit earlier of an idea where it's just like, I want to run this program, and then when it's done, I want to run the next one, and when it's done, I want to run the next one. Okay? The semicolon does exactly what I just said. It runs this one, and then runs that one, and then runs that one. It doesn't care what the exit status is. It doesn't care what the intent or what happened in the previous one. It just doesn't. And if you look at the output here, exit no matter 0, exit no matter 1. All right. If we go back to the code, it says exit no matter 0. Then it runs false, which always returns 1, which is bad, and then no matter what. Okay, so it just runs the first one, runs the second one, runs the third one, doesn't care. And ampersand is a different type of logic. It's a similar type of logic to the semicolon, except it actually cares about the exit status of the previous command. So it runs the first command, and it says, hey, the exit status is 0, because it successfully executed. Great. So it runs the next command, it runs false. False, so it's false. Who knew? That's the exit status of what? At that point, the next ampersand says, hey, what's the exit status of the previous command? False. Well, it's 1. That's not 0, and it drops out of the program. All right? So it's going to execute this one. It's going to execute this one. And it's not going to execute that one. And we can see that here, where we have exit matters 0, but we don't get exit matters 1. Okay. Any questions on inline logic? There's a lot more inline logic, but that's kind of important. No? Okay. Redirects. Redirects are great, and they're very useful. TEE is a great way of basically getting around these as well. But there's single redirect and there's double redirect. Single redirect is to overwrite whatever's there. Double is to append. So here we have first line foo1, second line foo1. We're getting single redirected into foo1. What's going to happen here is we're going to get this line into foo1. The next command, second line foo1, will overwrite what happened in the first one. All right? And so we're only going to end up with second line foo1. And we'll look at that. Here's second line foo1. All right? We don't get a first line because this guy overrode. Next one is append. Now append will always append. So first line foo2, foo2. Second line foo2, foo2. What's going to happen here is you're going to get both, but you will get anything else that may have been in the file before that. Because it was never cleared. All right? We didn't manually clear it, and we didn't have the process to clear it either. All right? So you can see that I've run this twice because it's in there, duplicated, because we don't ever clear it. So we're always appending that file. So we just run this 100 times, it's going to come up 200 times because we have put 2 entries in. Right? And the third example is wrong. Just the same as the first example. It's supposed to be that. So first line foo3, this would be a first impact. Like if I write a script, a lot of times I'll do it like this, where I'll have the first entry do a single redirect. And what that'll do is it'll override anything that's currently there. Then the next one will be append. Now you gotta be careful with this, guys. If you put this in a for loop or an if, some kind of a loop, guess what happens? Every time the loop's initiated, it erases everything. Okay, so if you want to do an erasure using a single redirect, do that outside of a loop statement. Even if you're going and you're just initializing the variable, you can just do this part. If you just do this, it will wipe out, it'll create the file if it doesn't exist, and if it does exist, it'll wipe out anything in the file. Okay? We'll do that outside of a loop, because every time the loop's run, it'll run that and you get hosed. Any questions on any of that term? Who's more? Nobody? Everybody? Alright. Terminal colors. Everybody likes colors. Alright. So, function colors. We can make all kinds of colors. There's a lot of colors in Bash, and they're fantastically useful if you're doing outputs of things. Now, I have problems with like backing out to the regular output again. You have to start like defining all your colors, which is what we saw at the very top of the program. But here, I use bash -e. -e allows for the /e. I forgot what they're called. Basically, it allows for the E statements. The E statements allow for special things to be put into echo. Here I say /e bracket 32M. Okay, so that's going to show me color 32 for there on. And so 32 is green. Then I say /e 34M. 34M is blue. /e 0M, that's white. /e 31M, that's red. And then /e 39M is actually standard, but standard's actually white on this terminal. It's like a thin white, and my standard terminal is green, like a thick green, and so it actually messes up my terminal. So later on, I actually switch it back to I think 32, and that's at the top of the program. So when it calls the menu, it goes back to /32. So we'll look at that real quick. All right, and remember so this is my original color here, and then switch to green, which is still the original color. Then it switched to blue, then it switched to white, then it switched to red. Okay. So you can do all kinds of colors and stuff in there. So it's like, hey, it's okay, put it in green. Hey, it's not okay, put it in red. Or you want to force the user to make a particular color on their terminal, that's fine. Be careful with that though, because, and also you might want to change the background. You can actually change the background, which we'll look at in a second. Let's say that I'm using a custom background and everything. So my background is black, and my normal text is green. Now, most Linuxes you're going to grab, like let's say you grab CentOS or something, it's going to have a white background with black text, right? Now let's just say that I force all of my output to be white. What happens on their default terminal? They can't see anything because the text color is the same color as their default background. And I'm forcing it to be white, so even though they force theirs to be white with green or something, or white with black, I'm forcing it in the program to be white. And so they just run this program, they're just like, what's going on? And it's there. If they select everything, they can probably see it, but you gotta be careful with that. So when you're forcing colors, it might be good to actually put a background color as well. That way you're forcing both the color in the foreground and the color of the background so that you can know that the user sees it in a particular way that you want it to be seen. This was a little script that I found on, there's a nice little site, which is this guy, and he's got all the colors and how to do that in the terminal. And so I snagged this script from his site, and I cited it there, and he actually is where I found that fun little GPL type of thing. by Sam But basically what this does is it goes through all the 256 colors of the allowable bash colors in the 256 color palette, and you end up with this fanciness, where it actually shows all of the different colors that you can have with the 256 color palette. And then those are the background ones. So you can do all kinds of different shades of different stuff. And there's all the different background colors. So there's a large variety of things. You can make it very pretty. Right? So you can probably draw like pictures and stuff, make a little like link or whatever on the terminal. But useful, fun. We gotta have fun while we're doing this, else you go crazy. Maybe you still go crazy, And lastly, we're going to do the remote function. So the remote function is very useful for sysadmins and people just trying to screw around with things. So like, let's say that I'm running an SSH server. Let's say that SSH server has a key on it, like this one. And I want to go and I want to see what's the status of a product, or like what's the output of a file, or something. I want to go and do something to a remote system. Now, remember when we did our bash -c with our sudo and everything like that? We do the same thing here. So we have SSH, secure shell, to JaxLUG.org, which is our server, don't tap it, and quote what I'm trying to do on that server, end quote. Okay. Now, if I didn't put those quotes, I believe what would happen is it would go to that remote system and run system control here, and then it would come back to our local system and then run status HTTPD, which is not going to work. So let's go to that.
Works on a computer.
No, I went to a terminal. And let's see. Remote. All right, here we go. So it went out. I have a key on that system. It went to that system. It ran what I tried to run, and it dumped that output back to my system, so I can see all the HTTP material from system D.
And yes, that just ran on the live server.
Yeah, I just read this. This is on our server that's hosting the wiki.
And the reason you didn't see a password is because, as I said earlier, he has a key.
Now later on, maybe for like a command line order or something, we can do like SSH. And I can show you how the keys work, and then like going to services, changing the passwords, or changing your running ports, protecting it, different things like that. Like this system, if you try to, let's say you tried to hammer a user. Well, one, you can't log into root. It's the first thing you should do on an internet-capable machine, because China will try to log into root 40,000 times in like an hour. It's ridiculous.
Like 15 minutes after your IP of mobile network on the internet, they will find it. On the public internet, obviously.
Yeah, you will be attacked. So, a couple mitigation methods for SSH real quick are, one, don't ever allow people to log into root remotely, because everybody knows that root's a real user. Right? On every system that's a Linux box, for the most part, unless you change the UI or the username of the root user, the root user's name is root. And by default, you can log on as root over SSH. So that gives them an attack vector where they say, I know a user on this system, and I know that this system's using that thing. So if I show you like attack logs where I can see somebody sitting there hammering the system, maybe a good 80% is root. Alright, they're just trying to hit root. Well, I disable that. So you try to log in root all day, you get the right password, that's great, you still not logging in. You can't get into it. Alright, so that's the first thing. The second thing is you can mitigate it by switching to a different port, which they will still hammer it sometimes, but one that is mitigated down a lot. Also, putting something like Bidleman or a different type of watcher system, they'll actually watch the logs and see if somebody fails enough times, and will actually ban them from talking to the server at all. And so I actually have Bidleman on try to log on to my server X number of times, and you fail that number of times, you get banned for at least a day or two from talking to the server at all. So all services will not be null for you. You can't talk to Apache, you can't talk to whatever's running, nothing. Just because the kernel will be like, oh yeah, that's great, you're at this IP drop.
Ever set up Port Hockey? You ever set up Port Hockey?
No, I have not, but I've heard of it. I don't really, I'm not familiar with the concept.
You need to basically try to connect on the specific series of ports and then
That's really fun.
yeah, so you get on the next ones.
That's really neat. I also need to look into, I know you can do dual authentication, so you can do your Google two off and
The U2F.
U2F.
Yeah. Then Google
2SA.
account.
2FA.
U2F is the
U2F
is like the YubiKey thing.
UBP
Oh, okay.
and now Google just released them.
Okay, I didn't know.
Google's actually, so they just released them, you can't buy them yet from them. They were using UBP before internally, and they were just like, why are we paying UBP and so on? So they were releasing the Titan ones, and the ones basically clone, and they have to just be interesting.
That's cool.
So you do workload things.
Yeah. So there's a bunch of innovation methods. Yes, sir.
One of the first things I do when I set up, like when I went from 19 and went back to 18, the first thing I do is enable fail to ban that. I've never really looked at the log file.
Oh, it's a lot of fun watching those log files. You can see them failing all over the place. Especially if you do fail to ban, you'll see them like try, gone.
Yeah.
Like a day later, try, gone.
Where am I going to find that log?
Well, it's the Etsy security log. So, no, not Etsy, it's var log security is going to be where your SSH failures are. And Bidleman has its own logs as well.
And yeah, the fun way you can also, the Filaban uses IP tables to ban you. You can just look at the table, the chain, fail to ban chain to see exactly who attacked you.
Right.
They usually run the firewall as a standard
Right. I think that the normal fail to ban policy is like 5 tries and then it'll ban it for like 5 to 15 minutes, I'm not sure exactly. You can make it a lot more restrictive, like 3 tries will ban you for 48 hours, which is much more restrictive.
Do you know an easy way?
Or you can have it forever.
Do you know an easy way to do geolocation for people if something like fail that?
Yeah, Filaban has it.
Yeah, but one you can actually go into the server, like you can accept particular ones, particular IPs. Like if you know that you come from this IP on geostat IP, you can disable that for a particular IP. But also, you can go in and disable the rules too with Bidleman. And so like you fail a couple of times on your own, and you lock yourself out and you go back into it. I don't know about GeoIP database. I know you can get GeoIP databases on the system, but I'm not sure if Bidleman actually locks into those databases. So you can do like, hey, if it's coming from the US, be less restrictive, be like 10 times, whereas if it's coming from China, be like 2.
IP tables has a link in for the MaxMind GeoIP database.
Oh, really?
So you could, at the IP tables level, simply default deny anything coming from not the US.
Okay, that's sweet.
And then the next entry in the IP tables would be, if it's SSH, head to the Filaban chain.
Cool. I switched off some firewalls at work when we've been using geolocation stuff now. It cut off so much noise.
Yeah.
Well, the ISPs over China don't really care.
Yeah.
They only care about incoming like freedom news. They don't care about what's going on. So, yeah. Was there a question back there? Anybody? Oh, I saw it. All right. Is there any questions? We're at the end of this particular module, so it's all a little bit. I'm sure there's people that would poke at it because they share the item or the DNS issue that I gave out for it. Yeah,
I saw that on Twitter.
it's great.
He got a mention at the closing ceremony too.
Yeah.
That was stoked. That was cool. So,
Well, the server's ready now.
yay.
Well done,
So
yeah.
we'll go ahead and stop recording.
I'll
This
have
will
to
be
look
on the internet soon, I swear.
I have to